We're going to talk about comparing fractions in this section. So let's go over some notation. That symbol is the less than symbol. Many times I might abbreviate it by LT. And this symbol is the greater than symbol, GT. So if you have this is read as A, starting from left to right. A, this means is less than B. A is greater than B. This is read as A is greater than B. Notice big times. So this is A is less than B. If we think of this as like an arrowhead, this arrowhead is pointing to the smaller number. I mean, it even says A is less than B. Now this says that A is greater than B. Well, there's only one reason why A is greater than B, and that's because B is smaller than A. Notice the arrowhead is pointing to B. It always points to the smaller number. Okay, so you have 7 and 5. 5 is smaller. Arrow goes to the 5. 11 and 13. 11 is smaller. So put the symbol that way. 2 and 8. 8 is smaller. Put the symbol that way. Notice I'm not even saying what this symbol means. I'm not even saying, oh, 2 is less than 8. 7 is bigger than 5. 11 is less than 13. Well, now I did, but if you give me any two numbers like 100 and 200, I could put the right symbol without saying less than or greater than when I put the symbol. This number is smaller than that number. It points to the smaller number. Okay, and we're going to be playing games like that. I'll give you two numbers and we'll decide which one is smaller than the other. Okay, so suppose the two numbers are 102. 2 is smaller, so the arrow goes towards the 2. 3 and 75. 3 is smaller. Arrowhead goes towards the smaller number. 82 and 86. 82 is smaller. So I put the arrow that way. 11 and 13. 11 is smaller. 8 and 13. 8 is smaller. Their symbol points to the smaller number. 2/3, 4/3. This is less than 1. This is more than 1. 2/3 is smaller. Arrow goes to the 2/3. If you have 8, which is more than 1, and 1/3, which is less than 1, the 1/3 is smaller. So the arrowhead goes that way. Okay, now I'm going to give you a list of numbers, and the instructions will be arranged from the smallest to largest. Generally, I will denote this as from small to large. Yeah, 2/7. you have 6 over 7, and you have 4 over 7. Now, you need to think of this in a way that makes sense to you. And that may not be the way that I'm going to explain it. But I think since it's always over 7, remember, this means 2 out of 7. This means 6 out of 7. And this means 4 out of 7. So you take this exam and they have 7 questions. And one of your classmates gets 2 out of 7 right. Another one got 4 out of 7 right. And another one got, 6 out of 7. And another student got 4 out of 7. The person who got the lowest grade is the one who got the smaller number of questions right. But they have to be out of 7. So it's going to be 2, 4, and 6. This student, 2 over 7 is the smallest fraction. This is bigger, and this is even bigger. I mean, what you can say is, you can add something to 2 over 7 to get 4 over 7, and that happens to be the same number. That means that this number is smaller than that. You had to add something to it to get equality. If you have 4 over 7, you can add something to it to get 6 over 7, namely 2 over 7. That means that this number is smaller than that number because you had to add something to it. So there's the ordering. If the denominators are the same, it's really simple. The smallest fraction will have the smallest numerator. The next one will have the next smallest one. And the last one will have the largest largest numerator. So if you have 8 over 15, 4 over 15, and 12 over 15, and you want to go from small to large, well, they're all out of 15, which is really nice. This is the smallest number, this is the middle-sized number, and this is the larger number. It makes sense that if you got 4 baskets out of 15, you did not do as well as a person who got 8 baskets out of 15, and that person did not as well as the person who got 12 baskets out of 15, or 4 questions out of 15, or 8 questions right out of 15, or 12 questions right out of 15. Now, in the next set of problems, we'll come back to these in a bit, but if you have 2 over 7 versus 2 over 5, and I want to know what symbol goes there, less than or greater than. Well, let's look at extremes. Say 2 out of 5 and 2 out of 1,000 versus, 2 out of 2,000. So who did better on the test? The one who got 2 questions right out of just 5, or the one who got 2 questions right out of 1,000? And I think it's obvious that getting 2 questions right out of 5, where it may not be such a great grade, is sure better than 2 out of 2,000. And 2 out of 2,000, 2 out of 1,000. 2 out of 1,000. And 2 out of 1,000 is better than getting just 2 out of 2,000. And you know what? If you got 2 out of 4 right, that's better than 2 out of 5. For example, if we have a pizza pie, let's have 2 pies. In one pie, you're going to cut it into 7 equal pieces, which is going to be somewhat hard, but please work with me. 1, 2, 3, 4, 5, 6, 7. Please assume that they're all equal in size. And here I do 5. 1, 2, 3, 4, 5. And again, assume that they're equal. Well, here you get to eat 2 out of 7. And here you get to eat 2 out of 5. Thing is, I must confess they look the same size. Well, the more you cut the pie, I mean, what if I cut the pie into many, many different pieces? Many different pieces. The more I cut the pie, your 2 slices are getting smaller and smaller. Okay, the more I cut it, the smaller your two slices would be. This is going to be smaller. Okay, that is going to be smaller. How about the next one? Suppose you have the following. 2 over 3 and 2 over 500. Which one is smaller? If we think of an exam, most people got 2 right. This person on the left got 2 out of 3 right. Not such a bad grade. This person only got 2 out of 500. Clearly, 2 out of 500 is not as good as 2 over 3. So that's why we say that 2/3 is greater than 2 500ths. How about 13 over 8 and 13 over 7? So you have 13 pieces of candy, and you're going to share it between 8 people or 7 people. Which one gets the least? And maybe 13 pieces of candy wasn't the greatest example. How about you have 13 grams of candy? So it's in powder form, and then you can divide it into 8 pieces or 8 segments, equal segments easily, as well as 7 equal segments. So you have 13 pieces, 13 grams of candy, and you share it between 8 people or 7 people. Well, the more people you share it with, it's going to be smaller. Okay, if only one person comes, they get all 13 grams. If 2 people come, they get 6.5 grams each. If 3 people come, they get 3 1/3 grams. The more people that come, the more people who share in on the 13, the smaller the fraction will be. Now, suppose you have 12 over 8, 12 over 6, and 12 over 14. And we want to go from the smallest to the largest. Well, the numerators I can put down in the right order because they're the same. Now, the more you share these 12 units with, 12 pizza pies, 12 slices, 12 apple pies, if you share it with 14 people, that's the most you're sharing with. that's going to be the smallest. If you share it within 8 people, that's the second smallest, and then 6 people, that's the largest. Now, this is also somewhat obvious because this is less than 1. This is exactly equal to 2, and this fraction, well, 8 goes into 12 one time, but not 2. So it's between 1 and 2. So yeah, this is less than 1, this is between 1 and 2, and that's 2. So yeah, that seems to be a reasonable ordering. It makes sense. Suppose you have 6 out of 8, 6 out of 22, and 6 out of 10. And again, we want to go from smallest to largest. Well, it's kind of obvious what the numerators are going to be for their ordered numbers. They're all 6. Well, again, you just need to look for the largest denominator, which is 22. And now the next largest denominator, and then the next largest denominator. There's your ordering. Okay, there is your ordering. The more you divide 6 by, the smaller it's going to be. If you understand that, life will be nice. But life can be hard sometimes. What if you have these 3 numbers? The tops aren't the same, the bottoms aren't the same, and the instructions is smallest to largest. Well, I would notice that this is more than 1. Okay, now when it comes to over 5, 2.5 over 5 is a half. So 2 out of 5 is going to be smaller. And you know what? When it comes to over 7, 3.5 over 7 is a half. So 4 over 7 is going to be bigger. Okay? So what I have is that this fraction is less than a half, 2/5. I have that this fraction, this fraction is bigger than a half. So of course, 2/5 is less than 4/7. Because this is less than 1/2, this is bigger than a half, and forget about it. This one's bigger than 1, but that's less than 1. It's bigger than a half, but it's less than 1. And 7 over 6 is bigger than 1. Using your half is not such a terrible idea. It helps out a lot. Look for a half and more than 1. 3/8, 14/25. Well, this is less than 1. This is less than 1. But 3 goes into 11 more than 3 times. So I know that 3 over 11, 11 over 3 is going to be the largest. So let me state that I want smallest to largest. So 11 over 3 is going to be the largest. Now, 4 over 8 is equal to a half. But we only have 3 over 8. So 3 over 8 is smaller than a half. But now, a half is equal to 12.5 over 25. But you know what? We have 14 over 25. This is bigger than a half. Okay, this fraction is less than a half. Let's put this symbol the right way. And this fraction is less than, is 1/2 is less than 14 over 25. 3/8 is less than 1/2, and 1/2 is less than that number. That is 3/8 is the smaller between these two fractions. And since this is improper, it's less than 1, and this is more than 1, there's your ordering. All just working with the number 1/2. But sometimes that doesn't really help. Maybe there'll be two numbers, if we have 0 and 1/2 and 1, maybe we'll have two numbers less than 1/2, or maybe two numbers bigger than 1/2. Sure, I know that this number here is less than this number. Okay, because a number less than 1/2 is always smaller than a number bigger than 1/2. But what if you have more than one number less than 1/2, more than one number between 1/2 and 1? So that brings up this rule. It says if A over B is less than C over D, then A times D is less than B times C. Notice that on the left side, so we multiply those numbers, but I put it on the left because A was the numerator between these two numbers. That's the numerator, and it's on the left. Between these two numbers, B and C, that's in the numerator, and it's on the right. That's one rule. But let me write it down so it can be read. I drew on it a lot. If A over B is less than C over D, then that happens. And if A over B is the bigger one, it's bigger than C over D, then A times D, so we have left and right. Since A is on the left, I write AD is bigger than B times C. C's on the top right, so BC goes on the top right. Just notice that the signs changed. Okay, so let me write this down again without any writing on it. If one fraction is greater than the other fraction, then this must be true. Okay, so suppose you have this. Suppose you have 2 over 3 and 4 over 7. Now, let's play the half game. Half of 3 is 1 1/2. That's a half. So 2/3 is bigger because I have 2 out of 3 as opposed to just 1 1/2 out of 3. But you know what? Half of 7 is 3 1/2, which is 1/2. And that's less than 4 over 7. So this number is bigger than 1/2, and this number is bigger than 1/2. But they're both less than 1. Now, there's ways of figuring it out. Like, for example, you had to add a half to get to the 2, and you had to add a half to get to the 4. Now, which half is larger? And the half that is larger is the one with the smaller denominator, because half of 3 is bigger than half of 7. Okay, But let us use the rule we just talked about. So let me write the problem over here. We need to figure out what symbol goes there. I multiply the 2 and the 7 and I get 14. The 2 was on the top, on the left. That's where I put the 14. 3 times 4 is 12. The 4 is on the top, so I put the 12 on the right. And then I decide which is larger or which is smaller. And I put the arrow pointing to the smaller one. Whatever arrow goes here, goes here. 2/3 is bigger than 4/7. Suppose you have 1/3 and 7/8. Well, 1/3 is less than 1.5/3, which equals a half. 1/3 is less than a half. Because when it comes to over 3, 1.5/3 is equal to 1. So 1/3 is smaller. And you know what? When it comes to 8, 4/8 is a half, but you have 7/8. 7/8 is bigger than a half. This number is less than a half. This number is bigger than a half. So the right number is bigger. But let us use this new rule that we have down. Make believe this sign isn't there yet. Well, 8 times 1 is 8. 3 times 7 is 21. The arrow points to the smaller number, so it's the same thing up there. Whatever symbol goes here, goes there. Okay. So, let's try this problem. Suppose you have 2/3, 7/8, and 1/4. And the question is to go from small to large. Now, notice that with respect to a half, with a 3 in the bottom, you need to have 1.5 out of 3. So this is bigger than a half. When it comes to 8 on the bottom, to be a half, you have to have 4/8. Well, this has more. So those two are bigger than a half. But that's less than a half. Because when it comes to 4, to get a half, you need 2 out of 4. This is only 1 out of 4. Okay, so I know that 1/4 is the smallest fraction. Which is the bigger fraction? Well, I can argue that 1.5 is close to 2. And 4 is pretty far away from 7. I would say that this one is bigger. But let's be sure. You multiply 2 and 8, you get 16. You multiply 3 and 7, you get 21. 16 is smaller. The symbol goes that way. That is, this number is smaller than that number. So it's going to be 2/3 and then 7/8. I knew right away that 1/4 was the smallest because this was the only number less than a half, and both of these numbers are greater than a half. You have to have some number experience. Numbers are fun. They're your friends, not your enemy. How about, same question, 1/2, 4/7, and 2/6. We want to go from smallest to largest. Well, clearly that's a half. Well, when it comes to 7 in the bottom, you need 3.5 on top. Oh, that's bigger than a half. When it comes to 6, you need 3 on the top. This has less. So at this point, it's kind of obvious. This fraction is less than a half, so it's the smallest one. This one is a half, and this one is more than a half. Let us try one more problem. Suppose you have, say, 1/2, and you have 8/15, and you have another number over 7, which is 3/7. You have these 3 fractions, and you want to put it in order from smallest to largest. Well, clearly that's a half. Now, when it comes to 15, half of 15 is 7.5. Okay, but we have 8/15, so that's going to be larger than a half. Now, when it comes to 3/7, 3.5/7 is a half. 1/2 is 3.5/7. But that's going to be bigger than 3/7. That is 3/7 is smaller than a half. And there it is, from smallest to largest. For the record, if you were asked to write it from largest to smallest, just reverse the order. Say 8/15, 1/2, 3/7. Okay, this finishes the section on comparing fractions.